kilometer, 6,400 kilometers, and one revolution, 24 hours. Okay. A11. What is the omega? The omega is 2 pi over t. 2 pi over 24 times 3,600. And the old calculator says that's 2 pi 24 times... What did you do wrong, AJ?
I didn't put radian for more.
No, it doesn't matter for this answer. 7.272 times 10 to the minus 5 radians a second. Okay, part 2. What?
No, there is 3 times is not 2 pi.
What?
No, this is it. Oh! No, because the question very clearly said radians per second.
Yeah, but mine is also reading.
360 is degrees.
Is it degree?
Yes!
Oh.
Teacher, why is that R method? I mean, why do we need the R? On
The next part.
On the calculator. But
Oh!
Yeah, the radian mode.
You need it for formulas not necessary for this question. The formulas that have cos omega and sin omega.
Okay.
Not necessary for this question, don't worry. What is the centripetal acceleration? V squared over r, with, but V is omega r. So that's omega squared r. So that's my previous answer, squared times 6,400,000. Yep.
Yep.
And that is
0.0.
tiny, 0.03384. meters per second squared. Now, is this acceleration upwards or downwards from the center of the Earth?
Upward.
Downward.
Up or down?
Down.
Down. Because we know it acts towards the center.
Oh, we could pin it there, under the, or
Yeah.
there.
What?
No, here.
No, but it's towards the Earth, so it's still downward.
Yeah, okay, here.
Okay.
In Australia.
Yeah.
This is still down for him. This is down.
It's towards the Earth.
Okay.
Yeah. Okay. B1. What's Newton's second law in terms of momentum? Newton said that force is the rate of change of momentum per unit time.
Oh yeah.
Yeah, he did. Right, part 2.
How do we write that?
Yeah, you can just say the rate force is the rate of change of momentum per time. Okay. A space rocket is standing before launch with a mass of 1.92 times 10 to the 3 kilograms. And then there's a fuel here of 7.4 kilograms per second is released at a speed of 2.5 times 10 to the 3 meters per second. What is the up force here? Well, if we remember, this formula is how much mass per second of gas multiplied by how fast the gas is coming out. That's the up force here. So in this case it will be 7.4 times 2.5 times 10 power 3. That's 18,500 newtons. Part 2. Why is there a delay? Well, remember, the weight will equal mg, which in this case will be 1.92 times 10 power 3 times 9.81. the weight is 18,835.2 newtons. So you can see that the weight is bigger than the force going up, which means it won't move until the weight will become less than the force. Although they don't ask it, how long will that be? Well, we need it to reduce by the difference in the force between the two is 335 newtons. In other words, the rocket is 34 kilograms too heavy, but it loses 7.4 kilograms in a second. So in fact, this rocket will take 4.6 seconds to launch.
How do we calculate that?
What I did was, Lee, I calculated the difference between this and this. That was about 300 newtons, which it was about 34 kilograms. So in other words, the rocket is 34 kilograms too heavy. It's losing 7.4 kilograms roughly a second. So dividing the 30 by the 7 means it's about 5 seconds you'll have to wait until the rocket is light enough to take off. Now they don't ask for that. It's only 1 mark. But I definitely have the 1 mark by writing all of this. A8 now, please. Yeah. 6 minutes. Go. Can I close this? Can I close?